So in this video, we're going to talk about how to evaluate composite functions. So composite functions are when you have a function that's within another function. So it's basically like taking a function and then applying another function to it. So what we do is we start off with our input x. Then we apply the function g, which gives us an output g of x. Then we're going to take this output g of x and then make it the input of f. And that gives us an output, which is f of g of x. And this is now a composite function because you see it contains the function g of x within f. So here's some notation that we use when we talk about composite functions. So composite functions can be written like this. So you see f, and then there's an open circle, and then g, and then we have x because x is our input. And it can also be rewritten as f of g of x. So I actually prefer this second type of notation. And when I see this notation, I'm usually going to rewrite it like this. So it's very important to note that order matters when you're talking about composite functions. F of g of x is not saying the same thing as g of f of x. In some cases, I know it'll work out that f of g of x equals g of f of x, but the process of evaluating these composite functions will be different. So now let's work on an example. So given f of x equals 6x minus 2 and g of x equals negative 3x plus 5, let's evaluate f of g of x and g of f of x. So let's start off with f of g of x, which I'm just going to rewrite like this. I'm going to write it like f of g of x. And so what I'm going to do is I'm going to take this g of x and I'm going to plug it into f. So that's basically the same thing as f of negative 3x plus 5. So I'm going to go to my f of x, and then instead of x, I'm going to plug in negative 3x plus 5. So that's going to give me 6 times negative 3x plus 5, and then I have minus 2. So now all I need to do is simplify this expression. So I'm going to start off by distributing the 6. So that's going to give me negative 18x plus 6 times 5, which is 30, and then I have minus 2. So now all I need to do is combine the like terms that I have, and notice that I have a 30 minus 2, so this is going to become negative 18x plus 28. And that is how I figure out f of g of x. And so now we still need to do the second part of this problem, which is we need to figure out g of f of x. So for g of f of x, I'm going to rewrite it like this. And then I'm going to plug in f of x, which is 6x minus 2, into g. So this is going to be g of 6x minus 2. So that means I'm going to take this expression for g, and I'm going to substitute 6x minus 2 everywhere I see x. So I have negative 3 times 6x minus 2, and then plus 5. So I'm going to start off by distributing this negative 3, so that gives me negative 18x, and then plus 6 plus 5. So now all I need to do to simplify is combine these like terms, which my 6 plus 5 will combine. So I have negative 18x plus 11. And that's going to be g of f of x. So that's how you find both f of g of x and g of f of x. So now you can go ahead and pause the video and try this example on your own. So we're going to start off by finding f of g of x. So that means that we take negative 4x plus 5 and plug it into f. So when we do that, that gives us 2 times negative 4x plus 5, which will simplify to negative 8x plus 10. For g of f of x, we're going to take 2x and plug it into g. So that gives us negative 4 times 2x plus 5, which gives us negative 8x plus 5. So now let's try this example. So it gives us f of x equals 3x minus 4 and g of x equals x squared. And now all we're finding is f of g of x. So I'm just going to go ahead and rewrite this. Like when I think about this, I just think about turning that into parentheses. So I'm just going to do f of g of x. And so that means I'm going to take this x squared and I'm going to plug it into f of x. So I have f of x squared. And so that means that instead of x, I'm going to have an x squared. So I have 3x squared minus 4. And that can't be simplified any further. So I'm just going to leave that as my f of g of x. So now suppose we have f of x equals the square root of x and g of x equals x minus 5. Let's evaluate f of g of x and g of f of x. So let's start off with f of g of x, and it does tell us that g of x is x minus 5, so we have f of x minus 5. So that means I'm going to go to f, and then instead of x, I'm going to plug in x minus 5, so that gives me the square root of x minus 5. That cannot be simplified any further, so I'm just going to leave that as my final answer. Now let's find the other half of this problem. Let's do g of f of x. So that means we're going to take f of x, which is the square root of x, and plug it into g. So that's going to be g of the square root of x. So I'm going to go to g, and then I'm going to plug in square root of x. So that gives me the square root of x minus 5. So I know this can be kind of confusing, but please notice that f of g of x and g of f of x are two different functions, right? Because in one of these, my minus 5 is under the square root, but in this problem, my minus 5 is outside the square root, right? This is the square root of x minus 5, where this, on the other hand, has everything under the square root. So now let's try this problem. We have f of x equals x squared plus 6 and g of x equals square root of x minus 6. Let's evaluate f of g of x and g of f of x. So let's start off with f of g of x. So f of g of x is going to look like this. We have f of the square root of x minus 6. So I'm going to plug in all of that everywhere I see x in my original problem. So I have the square root of x minus 6 squared and then plus 6. Well, when I square the square root of something, remember the square and square root are opposite operations that cancel each other out. So that's just going to leave me with x minus 6, and then I have plus 6. Well, minus 6 and plus 6 will combine to make 0. So this is basically x plus 0, which is just x. Okay, so f of g of x equals x. Now let's do the other half of this problem. Let's figure out g of f of x. So g of f of x is going to look like g of x squared plus 6. So I'm going to go to g, which is the square root of x minus 6, and instead of x, I'm going to plug in x squared plus 6. So I have x squared plus 6 minus 6, all under my square root. Well, plus 6 and minus 6 are going to make 0, so this is basically x squared plus 0. So I'm just going to, leave that as x squared. So now I'm taking the square root of x squared. Well, remember the square root and squaring something are opposite operations, so that's just going to be x. So that tells me that g of f of x is equal to x. So there's a star on this problem because notice that f of g of x and g of f of x both equal x. And this is going to be a special property that we're going to talk about a little bit later in a different lesson. So you can also evaluate composite functions at a specific value of x. Like if we're given a number that equals x, we can evaluate a composite. So the key to solving these problems is to remember to work from the inside out. Okay, so we're going to take our x and we're going to plug it into like our inside function. So if it's g, we're going to plug it into g. And then remember that output that we get for g of x is going to become the input of f. And then that's going to let us calculate f of g of x. So let's see what that looks like. So suppose we're given these three functions, okay? F of x equals 3 square root of x minus 2, g of x equals 5x plus 1, and then h of x equals 2x squared. Let's start off by evaluating g of h of 1. So I want to figure out g of h of 1. So what I mean by working from the inside out is start off by evaluating h of 1, okay? So I'm going to evaluate h of 1, which means I'm going to take this function h and I'm going to plug in a 1 for my x. So that's going to be 2 times 1 squared. Well, that equals 2 times 1, right? Because 1 squared is 1, and so that equals 2. So I know h of 1 equals 2. Well, what I'm going to do now is I'm going to take this 2 and I'm going to plug it into function g. Okay, so that's what I mean by the output becomes the input. So this g of h of 1 basically becomes g of 2, right? Because I know h of 1 is 2, so I'm just going to go ahead and plug this right in here. So g of 2 means I'm going to take my function g and I'm going to plug in 2. So I get 5 times 2 plus 1. So 5 times 2 is 10. 10 plus 1 is 11. So that is my final answer, okay? So you have to do like this sequence of steps before you can figure out the final answer. So now let's do the second half of this problem. Let's figure out f of g of 3. So we have f of g of 3, so we're going to once again work our way from the inside out, right? So we're going to start off with g of 3. So that means I'm going to go to this function g and I'm going to plug in 3 for x. So I have 5 times 3 plus 1, and 5 times 3 is 15, so I have 15 plus 1, which is 16. So now that I know that g of 3 equals 16, I'm going to take that and plug it into f. So that's going to give me f of 16. So I'm going to go to f of x now, and I'm going to plug in 16 for x. So that gives me 3 times the square root of 16 minus 2. And so I know that the square root of 16 is 4, right? So I have 3 times 4 minus 2. And 3 times 4 is 12. So I have 12 minus 2, which gives me a final answer of 10. So that's how you evaluate a composite function if you're given a specific number. So now you can go ahead and pause the video and try this example on your own. So once again, we have 3 functions. So if we start off by evaluating f of g of 3, I'm going to start off by evaluating g of 3. Well, g is 2x plus 3, so when I plug in 3, I get 9. Then I'm going to take that 9 and plug it into f of x. So f of 9 is going to give me the square root of 9, which is equal to 3. In part B, it asked me to evaluate g of h of 1. So I'm going to start off with h of 1. H of x is x squared, so h of 1 is going to be 1. I'm going to take that 1 and then plug it into g, so I have g of 1. And then g is 2x plus 3, so 2 times 1 plus 3 gives me 5, which is my answer for part B. So remember that a composite function is when you have a function that's within another function.